5 ahead. They even charge for kids.
They charge for reads?
They don't charge for reads,
Okay.
but they charge for 13 and up.
The supplement is pie. The supplementary is so it's pie minus.
Remember, complement can be made into a 9, the C, and S can be made into an 8, 1, 8.
1 minus 1.
So if you're finding coterminal angles with radians, you're adding and subtracting 360. So 3 pi plus 2 pi. Think of pi as a variable. I about did it.
3x plus 2x equals 5.
There you go. Think of pi as a variable because we don't want decimals. We want it almost like as variable form. So there's a positive coterminal angle. Bless you.
Thank you.
Now I'm going to take 3 pi and subtract 2 pi, but it only leaves me with pi, which does not meet the requirement. I'm going to put x as in like that's not what they asked for. So I'm going to bring that here and just basically take one more off. And now I have my 2 answers. Make sense? Pi over 3, we're going to treat this as 1/3. So we're going to add 2 pi. 1/3 plus 2 gives me 7 pi over 3. Then I'm going to take pi over 3 and subtract 2 pi. And we get negative 5/3 pi. Did you get that?
I don't think about it.
Complement and supplement. Remember how to make a C into a 9 and an S into an 8 to remember 90 and 180. Then you should have committed to memory that 180 is 1 pi, so 90 is pi over 2. So the complement and then the supplement. So this is the setup for me to get both answers. So this is the complement, this is the supplement. For the complement, did you get 2 pi over 5? And supplement 9 pi over 10? You can use your calculator. Remember alpha y equals for fractions or math frac. When you're dealing with pi, you can also do it in your head. Write the 1 pi as a fraction, remember it has to be 1, using the denominator of the other one. So 10 over 10 would be 1 pi. 10 over 10 minus 1 over 10 leaves me with 9 over 10. And then you can kind of see that one in your head. So complement. So I'm going to go ahead and do the supplement. I'm going to use 14. 14 over 14. That's 3 over 14. The complement you may not be able to do in your head right away, but you should have come to 2 pi over 7. And that's it for today.
Yay.
I wish.
Not quite.
No, we're shooting for an exam next Thursday so that they have a long weekend of no math. Are there any questions on that? Okay. Arc length and central angle. Okay. You're going to be uncomfortable with this, which is why there's 2 slides of practice. I've got the picture. I'm going to show you the diagram. I'm going to show you what the picture, like what the parts mean. But if this doesn't like make sense to you, there is the good old fashioned, there's gonna be a formula, you just need to know what to plug in where and then solve the formula, okay? So it'd be nice if you understand the concept and the procedures, but if you don't understand the concept, the procedure has a formula, which means you should be able to do that, okay? Arc length and central angles. This is very similar to what you learned in geometry. You learned arc length. Going back to geometry, arc length, so circumference is the whole length around, right? You with me?
Yep.
Okay, arc length is when you just want a section from here to here. So it'd be like if I said, what was the length of that cooked noodle, right? I know, sorry. So circumference is the whole way around. Arc length is just a portion. But we're talking about the measurement of it, okay? If you look at this picture here, we have the unit circle radius, which is right here, and they have a 1. And if you trace your eyes around that, like, message Chelsea Walker. You okay? Question mark. Couple months ago, there was a really loud noise just like that, and she had fallen. And she was like, "Did y'all hear that loud noise earlier today?" And I was like, "Yeah, I didn't know what it was." She goes, "It was me. I fell." So now that's the ongoing joke. Okay, so this is the unit circle radius, and if you trace it, it goes all the way around and creates that inner circle. And then this is just a random circle, not unit. That's why it says what? R. Yes. R for random. Meaning not the unit circle, it's just some other circle, right? If you trace that around, you get that outer circle. Okay, now focus on the red angle here, and then focus on the red little s sub 1, and then the black s. So there's a relationship between the angle that opens up and then the length of the arc formed. And we're not talking degrees, we're talking actual length, like linear measurement, but of course it curves. So we're talking about like if you had a ruler that would curve, like what would this measure? Okay, so this is arc length. All right, so let me give you the formula. We're going to start with theta equals S over R. Yes. Now, we're going to manipulate it because we don't always need theta. Sometimes we need S, sometimes we need R. But that is the beginning formula. Because of the rules in math, this is divide by R, so I could move this by multiplying by R. I'm going to multiply it over here to the right. So if I ever wanted S, then I could just multiply the radius times theta, and I'd have S. If I wanted theta, I could take S and divide the radius. If I want R, I would, what needs to move? If I wanted R by itself. Yeah, divide theta. So if I ever wanted R, I could take S and divide theta. All three of those mean the same relationship. It's just a matter of if you want a certain part by itself. Now come over here and look at this. Draw a big old line. Now you might be thinking, where did this come from? You know, did they just pull it out of thin air? Like, where did this relationship come from? It came from a proportion from this very picture right here. Notice S sub 1 is in the same general area as S, but S is clearly bigger because of the longer radius, right? So then you have the radius 1 that creates S sub 1. Then you have radius R that creates S. So here we go. S compares to S sub 1 as which radius made arc S? R, which radius made S sub 1? 1. So what I've done is I've just set up a proportion, right? Now we're going to cross multiply. I'm going to write in big letters or. So this is the like proportion that represents this picture. I don't like that R and S are on opposite sides, so I'm going to cross multiply this S sub 1, which is being divided. I'm going to multiply it to the right, and this R that's over here, I'm going to divide it to the left. You with me on how that's happening? So basically, these two are doing a switcheroo because of the cross multiplying act. So we got S over R equals S1 over 1. You see how I did that? This cross multiplied over here, and the R I divided to the left. Now, why did I do that? Well, because look at S over R, that looks really familiar, right? And then S1 right here, we're going to let S1 be theta. So if S1 is theta, then we now have S over R equals theta, which is what we started with. Now, everything we just did was just trying to explain to you where it came from, how we can manipulate it, what the picture looks like. Is that the actual math you're doing? No, that's not the math you're doing. I just wanted you to know where it came from, what it looks like in the picture. Okay? If you look down here at the bottom, we've got one of those blocks where it kind of sums up what you need to follow the next few slides. Let's take some notes on here. This is the formula we need. Theta equals S over R. You already wrote that up there at the top as well. Let's talk about what each part stands for. What does R stand for?
Radius.
Radius. I'm going to draw an arrow and make a note. As silly as it sounds, I would put radius there. Theta refers to an angle, right? Now here's what we've got to know. We are no longer in degrees. We are now in radians. So theta is the angle rotation, but it has to be in radians. Remember we learned yesterday how to convert from degrees to radians. By the way, Chloe, real quick on that. So if you do you remember like middle school when you would convert inches to yards, feet to yard, whatever? Okay, same exact concept. So you have to use the two units of measurement that are equal. So like if I was going from feet to inches, I would use that 1 foot is 12 inches. Okay, so if I'm going from degrees to radians, I would use that 1 radian is 180 degrees. So the fraction you multiply by is either pi over 180 or 180 over pi. It just depends on what form you're trying to get to. And the way you remember what form to use is always, it matches the one you're trying to get to. So if I'm trying to get in radians, I'm going to multiply the degrees, whatever, I was going to write a random number, but you would multiply the angle in degrees, I'll do this, angle in degrees, times pi over 180 to get the radians, okay? Okay, so we've not talked about S. S, draw an arrow, come back up here. S is that black arc formed as the angle opens up, and that would be the cooked spaghetti noodle. So this is the arc length. That's the actual arc length, which means, and I don't have a lot of room right here, so I'm just going to come past it. That means the distance traveled. So, for instance, if we had a word problem that said there's a satellite orbiting in the outer space and it travels a distance of whatever feet, yards, miles, that would be arc length. They've used the phrase distance traveled. Okay. Let's make a note here. There's one more thing you have to watch out for. So I'm going to put watch out. Watch out. S, comma, R must be in same unit of measurement. If the radius is in inches, but the arc length is in feet, you have a problem. Okay, so that's a lot, and that's why I dedicated 2 pages to practicing, or 2 slides. If you notice in the textbook, they only give you 2 to practice, and I'm like, let's do some more, because I think this is it's doable, and it's really not that bad. Everybody's always like, oh, actually, it's not that bad, but it's foreign to you, right? Like you're just not used to this at all. Okay, so we're going to do 6 practice examples, and then we'll call it a day. Okay, so that we're not flipping back and forth. Let's remind ourselves of the formula. We have theta equals S over R, and let's remind ourselves right here, theta has to be in radians. While these are word problems, the good news is they never change. So there's not a lot of ciphering going on. Like, you just read it and ask yourself, okay, is this the angle it's rotating? Is this the arc length, distance traveled? Or is this the radius of the angle, like the circle? Okay? Everything is straightforward. So read number 7. Find the measure of a rotation. Bam, right there is telling me I don't know this. Now, what variable represents the rotation? Theta, so I'm going to put theta question mark. This lets me know that I don't know theta. That's the goal. In radians, when a point 2 meters from the center, what's that? That's the radius. So the radius is 2 meters. Travel, so the 2 points, or what is it? When a point 2 meters from the center of rotation travels 4 meters. That's S. They're telling you the distance traveled. They didn't use the word distance, but you have to visualize an angle's opening up. We don't know the measure of the angle. There's a radius of 2. And they're giving you S is 4 meters. It helps to write your unit of measurement after it so that you'll remember that they have to match. In a formula with 3 variables, you would need to know how many to be able to solve it. 2. They're always going to give you 2. Okay? So now let's set it up. And I'm just taking notes. You don't have to write what I'm about to write. So we are trying to find theta. And I'm going to copy that my radius was 2. My S is 4 meters. These match right here. I'm going to put a little check mark, like meter and meter. That's me just kind of organizing my thoughts like, okay, here we go. Plug it in. It's just plug it in. So theta equals S over R. S is 4, R is 2, so theta is what? 2 radians. radians. Now, you might be thinking, so the angle's 2, but it's radians. What did we say radians is about yesterday? Do you remember?
Like 51 points.
57. So you don't have to draw this, I'm just trying to give you a visual. So if it's about 2 radians, then it's opening up, 57 plus 57 is
About 100.
114. So it's definitely opening up past 90, right? And then it's landing here. So this would be 2 radians right there. And then we found theta to be 2 radians. It's opening up, it's traveling 4, the radius is 2. So this is the picture. And theta is about 2 radians or 114 degrees-ish. Picture's not necessary. I'm just trying to help you wrap your mind around, like, what am I actually working on here? Because, you know, if I say Pythagorean theorem, everybody knows right triangle, sides of a triangle. If I say arc length, radian measure, like you're not really, it's like, okay, what's that look like? All right, let's try 8. Find the length of an arc. Okay, that would be which one? That means we don't know S. Of a circle with a radius of 5, that's what? That's R, centimeters. Associated with an angle of pi over 3 radians, that's what? That's theta. Bless you. That's enough. That's it. So I've labeled my word problem. I know what I'm looking for. I've got my 2 that I know. Now I'm going to take my little notes over here. So I'm going to find S. I know theta is pi over 3, and I know R is 5 centimeters. All right, let's plug it in. We have, so I did this 2 ways last year. So you can go the way we've been going, theta equals S over R. Nothing wrong with that. Plug it in, manipulate it. But what am I trying to find again?
Yes.
I'm trying to find S. So what can I do to the formula before I plug stuff in to help it easier on make it easier on myself to find S? I could multiply this. This is why we did this on that last side. I could cross multiply this R over, and I'd have R theta equals S. And now I have the one I'm trying to find is by itself, so now I'm just going to plug them in. So I'm going to go with this one here. I'm going to draw an arrow because it's backwards. S equals R theta. You don't have to do that. I'm going to do that. That's just me. All right, what is R? R is 5. Theta is pi over 3. And we are looking for S, which is the length of the arc. So if I said 5 pi over 3, does that tell you the length of something? No, that's confusing and makes it sound like it's radian measure, right? So we need to type the whole thing in the calculator. Like type it all in. Alpha y equals 5 pi, arrow down, 3. And you get approximately what? I just went to 10. 5.2?
Yeah.
So about 5.2, and we were talking about centimeters. Now that answer makes sense. So the textbook thinks, oh, well, you've done 2, you're good to go. Well, notice we didn't practice a single one where we had to fix the unit of measurement. So I was definitely like, okay, we need another one of those. And we didn't practice where you're finding R, which actually I don't think we have one of those on here. We don't. That's not too bad. Let's arrow to the right and let's do these 4 practice problems. Let's copy our formula. Oh no, you're on the same page. I'm gonna copy it here. Theta equals S over R. Remember, theta has to be in radians. There is an alternative formula. If you cross multiply the R over, you have S equals R theta. So that's an alternative formula. I don't have that memorized. I got that by cross multiplying that R over, right? All right, look at E5. E5 is straightforward. Everybody try it. Should come to 24 radians. Miranda, there's something by your under your desk. Is it a battery? A watch battery? No, that's too. A cap. Something. Oh, it is. Oh. Did y'all hit 24?
Yes.
All right, so find the measure of rotation in radians. So the rotation in radians tells me I'm looking for what?
What'd you say?
Like, this is my clue that I'm looking for
Oh, theta.
theta. So I'm looking for theta. They say a point 0.25 miles from the center. That's your what?
R.
That's your R. We'll put MI. And then it says center of rotation travels 6 miles. Travel 6 miles is your S, and it's also in miles, thank goodness. So since I'm looking for theta, I'm going to use theta equals S over R. S is 6, R is 0.25. And theta is a unit of measurement referring to angle rotation. There was a really loud noise and I worried if you fell again. She wrote back and said, yeah, why? All right, let's look at E6. Go ahead and take notes on the problem, like underline what you're looking for, underline what they give you. Take notes real quick, and let's see if we get the same thing there. So a 20-foot diameter will be a big circle. What do I need to write? D equals 20? No, what should I write? Yeah, remember, we don't want the diameter, we want the radius. So you got to remember that relationship between a radius and a diameter. If you're one of those students who confuses which one's the bigger one, use the length of the word to remind you. The diameter is the bigger word. Radius is the half one, Okay. So if the diameter is 20, then the radius is 10, and we're going to put feet. It says, in a circle with a 10-foot radius, an arc 4 feet long subtends. This is another way of telling you distance traveled. Okay? Subtends means lays out. An arc 4 feet long is giving you S. It subtends an angle. So this arc that I'm going to lay out 4 feet long would create what angle in radians? So this is saying find theta, right? All right, so theta is S over R. S is what? 4. R is 10. When you divide that, you get just the decimal 0.4 radians. Now, let's practice go into degrees. It says how many is it in radians? Oh, then it says degrees. I missed that. All right, so you want the decimal. Radians is always in decimal form when you're multiplying the pi. If you're leaving it in pi form, like a variable, then it needs to be as a fraction. Okay, so if we're going from radians, this is good practice for you because you weren't here yesterday. If I'm going from radians, 2 degrees, 180 needs to be in the top. So I'm going to multiply 0.4 times 180 over pi. Now, because I don't see pi in the 0.4, like it doesn't say 0.4 pi, like there's no pi there, that means you have to type the whole thing in. So you're going to go to your calculator and type 0.4 times 180 over pi. Brody, wake up. If it was 0.4 pi, then you would just enter 0.4 and 180. The pi's would cancel. Yeah. I just went to the nearest 10. Yep. No, because it's not exactly 57. Yes, you can. Yeah, you can. That's fine. You could use that as a checkpoint. But as far as you know how my math lab is, as far as rounding goes, it would take off part of the actual value. Yeah. You could use it as a calibration. Like if I know 1 radian is about 57, and this is close to half a radian, then I know about half 56. So you could use it as like in my, what is it, and put it in perspective. All right, go to E7. Try it. Try E7 and just go ahead and try E8. I'm going to write the answers and I will work them, but I want to see if you can get them on your own. Yes.
to 165?
Yes.
Alright.
Did you use theta equals S over R? Or did you use a different one? So I would write this and then I'd go to plug it in and I'd be like, well, no, wait a minute, if I plug it in, I don't have S by itself. So I'll cross multiply that theta up, and now I can see, okay, I'm just going to multiply R times theta. So 8 times pi over 2, and because we're talking about, what are we talking about? The length of an arc, we need to actually type it in the calculator and get the decimal. And that's where you get 12.6. So we have another question where we're finding S. So I'm going to use S equals R theta. And you get 165. Now, none of these involve changing the unit of measurement. And you really, it doesn't happen a lot. It doesn't happen, I don't think, at all with this. It's the next slide where we start talking about what's called linear speed and angular speed. And that's where you'll notice a preview of what's to come. Tomorrow's slide, we're going to learn these formulas that have a different, this is taking into account speed, not length necessarily, an angle measure. Now we're talking about how fast did it go, okay? We're going to learn those. And then this just sums it up in another pretty picture. And then we have 1, 2, I didn't feel like that was enough. 3, 4, 5 practice problems. And we will practice converting from one form to another. So that's the end of 6-4 for tomorrow that we'll do, okay? It's heavy, but it's the same stuff over and over. It's just, again, it's unfamiliar math. Like, you're just not used to working with angular speed because this isn't a physics class. Yeah.
Are those